Welcome to multiple choice question 20 of the 2008 Mathematical Methods Exam 2. In this video we will be looking at the solution for this question. A reminder that this video is in no way endorsed by VCAA. And now before we move on to the problem, I'd just like to point out that the use of a CAS calculator is a great way to answer this question. For question 20 we have the function f with some domain b with a rule f of x equals 4x cubed plus 3x squared plus 1. Will have an inverse function for one of the following domain restrictions. So to have an inverse function, we need the original function f to be 1 to 1. So to work out how we can restrict f to be 1 to 1, we can use a calculator to sketch the graph of f. On the CAS calculator, go into the main menu. Next, we want to type out the expression for f of x, so that's 4x to the power of 3 plus 3x to the power of 2 plus 1. Next, we want to hit the graph button so that we can sketch a graph of this. And we're going to drag that down. I might even zoom in a little bit. And we're going to go analysis, gsolve minimum to find the minimum stationary point, and analysis, gsolve max to find that maximum turning point. And hitting escape will just clean that graph up a little bit for us. So we can see that there's a turning point at negative 0.5 and a turning point when x is 0. So now what we want to do is we want to look for a suitable domain restriction so that that graph is 1 to 1. So in other words, we need it to not include any of those turning point or curves in the graph. We just want a 1 to 1 function. So having a look at our options, we can rule out option A because that doesn't restrict the function at all. So it's going to have those turning points in it and it's not going to be 1 to 1. And then looking at B, we can see that if we were to restrict it at a half, which is somewhere up here, there's no turning point. So if I just drag that over a little bit, we can see that it is 1 to 1 from a half onwards. So it looks like that is the correct answer for this question. But what we could do on the calculator is we could just drag this down and then put that restriction in. So we can go math 3 given that. And we want to say x is greater than 0.5 or x is greater than a half. Then going back to our graph, I'll just clear this out for a moment. And we're going to drag down from the left-hand side with the restriction that x is greater than a half, which is option B. And again, that does confirm, even if I zoom out a little bit, that this doesn't include any of those turning points that we found before. So that is the suitable restriction so that it's 1 to 1. And that will give an inverse function. So if I just copy out the graph with the restriction x is greater than a half onto this set of axes, the graph just looks like this, where this endpoint would be an open dot at 1/2, and f of a half you could work out is 9 on 4 if you wanted to. And it is now 1 to 1 for all x is greater than a half. So that does confirm that B is the correct answer for this question. And now if you looked at any of the other options, all of them would include a part of the graph that turns on itself. So it wouldn't be 1 to 1, so they wouldn't have inverse functions, they would have inverse relations. So once again, B is the correct answer for this question. From the examiner's report, we can see that this question did challenge a number of students, with only 50% of students getting the correct answer for this question.